Today we're going to do something that's a little more interesting, at least for me. I enjoy this kind of thing because it's a little bit of a, you got to think, it's not exactly, and it's pretty because you get to color. I'm all good with coloring. So today we're going to talk about combined inequalities. So the first thing you need to know is that there are two kinds of inequalities that can be combined. It can be combined with an and kind of statement, or it can have an or kind of statement. If it's combined with an and kind of statement, that means that the two inequalities, you want the answer to be what they have in common. If it's an or kind of statement, you want everything in both answers to be part of your answer. So for this one right here, these are all considered and kind of equalities because they're all in one statement. They don't write an and everything, but it's considered an and inequality because it's all combined in one statement. So combined inequalities always end up having two or more inequalities in the statement. So I have one here and I have one there. When they're combined like this, it makes life really easy, because you know what the two numbers are that are important. We have the -1 that's important, and we have the 2 that's important. And don't forget, I put my 0 in there somewhere. Now, is the -1 going to be a solid circle or an open circle? Well, it's going to be solid because it has a line underneath it. So it gets a solid circle. Is this one going to have a solid circle or an open circle? It's going to be open because it has no line underneath it. When you have the X in between the two numbers, that means you shade in between the two numbers. That's why I like these, because they're really easy to do. Sometimes, though, they write the statements out like they did in number 2. So for that kind of problem, you kind of need to make sure you map out what both of them are. So the first thing I'm going to do is go ahead and put my numbers up here. So I know we got a 21 we're dealing with, and over here somewhere is 0. And we got a 22 we're dealing with. So for the first one, it says X is greater than or equal to 21. That means that this is going to be closed, and it's going to go that way. Notice I didn't put it on my graph. I just want to get some idea in my head of what it is. So I do it a little bit above the graph. And for this one, it says it's going to be closed and going that way. So this one looks like that. But since it's an and problem, and this is where my answer goes, that's what I want on this one. So the question is, what do they both have in common? Do they both have shaded at 21? Well, yeah, the pink one is shaded at 21 because it's got its circle. So that's done. And then the blue one is shaded at 21 because it covers by it. And this one is shaded all the way up to 22, and it has this dot there. But there's nothing past. They're not both past 21 this way. They're not both past 22 that way. It's just the stuff in between that they had in common. And that's what your answer is, the stuff in between that they have in common. For this one right here, we're talking about 5. For the first one, it's open on 5 and going that way. For the second one, it's open on 5 and going that way. So did anything get shaded in both? The top one and the bottom one? Well, no, they both got open circle on 5, but that just means that there's nothing there. So since there isn't anything in any of this, I don't have to graph anything. My answer is no solution because they don't cross anywhere. There's nothing to graph. This one looks just like the one before, where I have a -4 and I have a 5 and there's a 0 somewhere in between. Over here it's an open circle on -4, open circle on 5. Since the X is in between the two of them, that means I shade in between the two of them. Don't have to think about it. But for number 10, we have an OR problem. Now our numbers are 0 and 3. So I can go ahead and put those up there. But for the first one, X is less than or equal to 0. That's right here. And it gets a solid dot and shaded this way. For the other one, it says X is greater than 3. So that's going to get an open dot and shaded this way. Huh. You know, I didn't put that on top. I just put it on my line. Do you know why I didn't put it on top and I just put it on my line? Because whatever's on top has to go on your line in an OR problem. In an AND problem, it doesn't. In an AND problem, you're looking at what they have in common. But in an OR problem, everything on top gets put on your line. So I just go ahead and draw it on my line. It makes things go a lot quicker that way. Let's look at a couple more. Number 12. M is less than 3 or M is greater than or equal to 3. Number 20. -10 is less than or equal to 12R plus 2 is less than or equal to 14. A real problem. I like them. For number 12, remember I said if it's an OR problem, all you have to do is graph both the things that are there. So I got my 0 down here, got my 3 up here. This one says it's open circle going that way. This one says it's a closed circle going this way. So it ends up being all real numbers. Because everything got graphed. Whole thing's all shaded in. Number 20 is kind of different because there's actually something to do. You don't just graph it. There's something to solve for it. So when you have an inequality, before we were taking and drawing a line underneath our inequalities. Now we have two inequalities, so we're going to have 2 lines. We ain't never had to have 2 lines before. This is definitely new. So now that we have 2 lines, we still want to get our letter by itself, but we don't want it over here on the left-hand side. We want it in the middle, because that's what made our graphing easy. So if I want to get my letter by itself in the middle, the first thing I need to get rid of is that 2. So I'm going to subtract 2. If I subtract it from here, I have to do it in both of the other places. So -2 and -2. That's going to make it go away here and leave me with 12R. Over here, -10 and -2 is -12. 14 and -2 is +12. And now I need to divide everything by 12 so that I can get the R by itself here. It's a +12, so I don't have to worry about flipping my signs. That gives me a -1 and a +1. And whatever my sign was up here, that's what it is unless we have to change it. So I have my -1, my 0, my 1. It's closed in here, closed in there. And since the R is in between, I shade in between. Two more. $24. That's an X. And then 26. I don't think 26 is going to fit, but I'm going to try it anyway. I'll give you a second to get into trouble. No need to pause. Draw my two lines. 3x plus 3, 9. Subtract 3, -9, 3x, and 6. Divide everything by 3, and since I'm dividing by a positive number, no need to flip anything. So that gives me negative, 3 is less than x is less than 2. Open here, open there, shade the stuff in between. $26 is different. It's like two problems for the price of one. So for the first one, 3m minus 9 is greater than -3. Add 9 to both sides. 3m is greater than 6. Divide both sides by 3. M is greater than 2. Or the -8m and -24. Divide both sides by -8. When you divide by a negative, you have to flip your sign over. M is less than 3. My 0, my 2, and my 3. M being greater than 2 means it's here with open going that way. Or means everything gets shaded. M going less than 3 means it's here open going this way. So our answer ends up being all real numbers because it's an or problem. If it had been an and problem, it'd just be the stuff in between the two of them. But because it's an or problem, it gets to be all real numbers. Get right with this one. Classwork. You'll like me, I promise. Page 205. Numbers 14, 22, and 30. 3 problems. It's pretty good. Homework. Page 205. Numbers 1, 5, 9, 13, 17, 21, 25, and 29. 8 problems. See you next time.